Sixth-generation cellular systems are expected to operate at higher frequency bands, including millimeter waves and terahertz frequencies, to achieve high data rates and low latency. At higher frequencies, radio waves are more easily absorbed by air and objects, so coverage can be an issue. A solution could be the deployment of reflective intelligent surfaces. These are panels made of special semiconductor materials that reflect sixth-generation signals in the desired direction. Typically, they are made up of many tiles of elements, each adding a different delay to the incoming signal before reflection. By properly tuning the delays, the signals reflected by all the elements will sound coherently at certain points in space, improving the quality of the reception. This makes it possible, for example, to steer a signal coming from a base station to a specific position where the intended receiving user is located, thus increasing coverage. Beyond coverage, reflective intelligent surfaces can also be used to improve network security. The European Robust 6G project is investigating the use of reflective intelligent surfaces in various security mechanisms. Thanks to their ability to modify radio propagation conditions with appropriate signal reflection, they can give legitimate users an advantage over potential attackers. For example, by focusing the signal towards the legitimate receiver while providing a coverage hole in the correspondence of an eavesdropper, a message can be transmitted confidentially. Reflective intelligent surfaces can also be used to provide various other security mechanisms such as authentication and secret key generation, or to detect and mitigate denial of service attacks based on jamming. To fully exploit the potential of reflective intelligent surfaces, a new security paradigm must be adopted, based on the properties of radio signals and their changes in what is called physical layer security. At the University of Padova, we study how reflective intelligent surfaces can be used to authenticate messages, to ensure that a received message was really sent by a particular user. This is important in several applications, where an attacker can impersonate the legitimate user to cause damage or for his own benefit. For example, when sixth-generation networks are used in industrial automation, a control message sent by an attacker to a robot can disrupt industrial production with severe damage and losses. Reflective intelligent surfaces can mitigate such attacks by providing the robots with the messages only from the specific place where the legitimate transmitter is located, thus limiting the area to be monitored against attackers. Moreover, the reflections of radio signals on surrounding objects introduce specific features that can be detected and act as a fingerprint of the transmitter. A legitimate node will have a different fingerprint than the attacker node in a different location. Thanks to their ability to shape the radio environment, reflective intelligent surfaces can enrich such fingerprints and improve the detection of attackers. Reflective intelligent surfaces can redirect signals coming from specific spots to another location where a receiver can pick them up. Because the point of focus can change over time, this provides a scan of the radio environment that can be used to locate a device that is transmitting jamming signal to disrupt ongoing legitimate communications. The deployment of reflective intelligent surfaces also creates new threats to sixth-generation networks, and the Robust 6G project is helping in identifying them and provide new security mechanisms. For example, a reflective intelligent surface controlled by an attacker can be used to reflect jamming signals to specific devices or to change the radio propagation environment and disrupt authentication. Also, knowing the presence of reflective intelligent surfaces, the attacking device can be placed in specific position to eavesdrop on exchange signals or to perform more effective attacks. Robust 6G will significantly contribute to better understanding the potential and limitations of reflective intelligence surfaces from a security point of view. A first step in this direction has been the drafting of a threat matrix that collects a list of threats, attack surfaces and threat definitions for specific cellular scenarios. The matrix also lists security mechanisms that use reflective intelligence surfaces. The threat matrix will be used to guide next steps of the research project and will lead to new solutions that can be adopted in the standard of future 6th generation networks.